Okay, I only asked you to do 2 questions over the weekend that were for homework, and then I asked you to work, of course, on the back side of this sheet, which is the assignment, and it's going to be due later in the week. So the first question was number 6. And it wants you to find the solution using significant digits. So first you're going to add these 3 up. And when you do, you get 14.106. But then the rule for sig figs is only you keep the least number of decimals. So this first one has 3, this one has 1, this one has 2. Means you can only keep 1. You look to the number to the right of it and it's a 0, so you do not need to round up. This becomes 14.1. Final answer. The next one you're multiplying. So when you multiply these 2 numbers together, you get 28.6578. Rule for multiplying is smallest number is sig figs in the things you were multiplying. First one has 4, second one only has 3. The front 0 does not count, but the back one does. So this one has 3, which means I'm only allowed to keep 3. So this first decimal spot has to be my last one, but the one beside it to the right is a 5, which means I need to round up this time. This will be 28.7. Okay, and now in this one we're dividing. So first you divide and you get 8.0176. And then dividing is like multiplying. The smallest number is sig figs. This one has 2. This one has 4. I'm only allowed to keep 2. And so this will be equal to 8.0. And I'm done. All right, the next set is converting. So for the first one, we're going from meters to kilometers. So I'm just going to change this to a times. And my conversion factor needs to have kilometers on the top and meters on the bottom. Put a 1 on the larger one. And there's 1,000 meters in a kilometer. So I'm going to divide by 1,000. And this is going to become 0.0039. Or if you want in scientific notation, 3.9 times 10, sorry, I'm just off the page there, 3.9 times 10 to the negative 3 kilometers. It does not matter to me which way you write it. The next one is kilometers going to meters. So this time the kilometers has to be on the bottom and the meters on the top. Put a 1 on the bigger one, which is kilometers. 1,000 meters in a kilometer. Multiply 8.6 by 1,000 and get 8,600 meters. This one we're going from millimeters to kilometers. So there's going to be 2 factors. First, millimeters to meters. So put meters on top, millimeters on bottom. Put a 1 on the larger one, which is the meters. 1,000 on the millimeters. Second factor, kilometers are going to be on the top. Meters on the bottom. Put 1,000 on the put a 1 on the larger one. 1,000 meters in a kilometer. So you're going to take this 32.8 millimeters and divide it by 1,000, and then divide it by another 1,000. And so when you do, you're going to get a lot of 0.00. I'm going to write it in scientific notation. It's going to be 3.228 times 10 to the negative 5 times 10 to the negative 5. And that'll be kilometers, right? Because it goes over 2, another 1. Yeah. All right. Kilometers per hour to meters per second. Again, 2 conversion factors. The first one is going to change kilometers to meters. So meters has to go on the top, kilometers on the bottom. 1,000 meters in a kilometer. And then hours needs to go on the top because here it's on the bottom. So 1 hour. And on the bottom, 3,600. And when we do this, we're going to get multiply by 1,000, divide by 3,600. You should get 22.7. And the 7's repeating. Meters per second. All right, the last one, meters per second to kilometers per hour. So meters has to go on the bottom, kilometers on the top this time. A 1 on the kilometer, 1,000 on the meters. And then you want to get rid of the seconds, which is on the bottom. So it's going to go on the top in the conversion factor, hours on the bottom. So it's going to be times 1 on the bottom, 3,600 on the top. So multiply by 3,600, divide by 1,000, and when you do that, you should get 79.2 kilometers per hour. Okay? So that was it for the actual homework. Then I did ask you to work on these, and hopefully you did okay on those. And if you need help, I'm in my room every day at lunch. Come and work on them in there. Okay, so for those, the next thing I'm going to do, and some of you already have it. So for those of you that I've already gone over this in class, you can stop the video here and go to the next one. The end of this video, for the people who haven't done this, I'm going to go over the steps in problem solving. Okay, so some of you already got this in class. It just depended on how quick we went, and some of you didn't. So if you already have the notes on this, move on. But the rest of you, you need to watch this, okay? All right, so what we didn't finish in class today, and you may want to, I'm just going to make this a little higher so we can get it all in here. You may want to, you should probably write this down, so I'll just focus on it here. Maybe if I make it bigger like this. Okay, so it's steps in problem solving, and these are the steps that I want you to use when you're solving problems in physics. So the first one is pretty straightforward. Read the problem. Read the problem. And then write down the things that you are given. So the question might say an object starts from rest and it speeds up to a speed of 20 meters per second. In math, some of you have a really bad habit of just going through the question and picking out the numbers. Read the problem. And then write down what is given. And then the last part is, are there any givens that are not said explicitly? In other words, that you actually kind of have to interpret. So there a minute ago I said an object starts from rest and speeds up to a speed of 20 meters per second. The starts from rest means VI is 0, but it's not given explicitly. So that's what that means. Okay, and then what are the values you're solving for? List them. It might say, how long did it take to travel 100 meters? And so you would do delta t equals question mark. Now check the units. Do any need converting? Are there some of them in meters per second and some of them in hours? If they are, then you need to convert. And in physics, we always use meters and seconds usually. Then it says draw a diagram or sketch of the problem. So it doesn't need to be a piece of art. And when we get into the more complicated ones, you really have to do this. In these first ones, it's okay, but as we get more complicated, a sketch will help you. Determine the equations to be used, and it should say, and write it down. Okay? And then once you have it written down, simplify and rearrange it so that you get the unknown value by itself. So the way we've been rearranging equations, so you have x equals whatever. So you're going to not fill in any of your numbers till you rearrange it for the unknown value. Once you've done that, then you're going to substitute the givens in with their units, and you're going to solve for the unknown. Okay? So with their units, you have to put the givens in and carry your units all the way through. Solve for whatever it is you're solving for, if it was time, whatever. And then in the last question, you need, it's as radical as the first one. The first one was read the question. The last one is the result reasonable? Does it make sense? And probably we should say, does it answer the question? Okay, so at the end, stop and think about it. You know, if you were finding the speed a person was running and you end up with, I don't know, 120 meters per second, you might have done something wrong because not many people can run that speed. So that's what it means when it says, is the result reasonable? Does it make sense? Okay, so as we do problems in physics, we will be following these pretty much. Some of them we won't have to do because we won't have to change our givens, but we'll have it in the front of our mind as we go through the steps. Okay? All right, next video.